Welcome to the Viterbi School of Engineering Faculty Roundtable for the Biomedical Engineering Department. My name is Paul Ledesma. I'll be the host for today's session. I'm the Director of Undergraduate Admission. It's a pleasure to have so many people here today learning more about the Biomedical Engineering Department and program. And we have a fantastic and really lovely group of faculty that are going to be able to talk to you about the department. And I don't want to waste any time. Let's do some introductions, have each of them introduce themselves, tell them a little bit about who they are, where they came from, how they found themselves at USC, and what they're doing at USC. Just because this is the order in which you're on my screen, we'll go Jesse, Megan, Unji, Christina. So Jesse, why don't you kick it off?
Sure. Hello, everyone. My name is Jesse Yen. I am an associate professor in the BME department. I teach the Intro to BME class, so should you come to USC, you'll probably see me your first year. I've been at USC for about 17 years now. I did my PhD at Duke, and my area of research is in ultrasound. So I develop novel ultrasound imaging devices, novel ultrasound image processing techniques. So a little bit of hardware and a little bit of software.
Great. Hello, everyone. Thank you for being here. My name is Megan McCain. I was born and mostly raised in St. Louis. So I went to Washington University in St. Louis for my undergraduate degree in biomedical engineering. Then I went to Harvard for graduate school, where I got my PhD in engineering sciences with a focus on bioengineering. Then I came to USC. I started in 2014 in the department as an assistant professor. I also have a courtesy appointment in the Department of Stem Cell Biology and Regenerative Medicine. I teach BME 410, which I'll talk more about later. It's the Introduction to Tissue Engineering course that many of the juniors and seniors take in our department. My research is related to that. So my lab is a very different area of biomedical engineering than Professor Yun. So we do tissue engineering primarily for the heart and other types of muscle. And basically what we're trying to do is grow very small pieces of human tissue in the lab that we can then use for drug testing. And we try to use cells that we can derive actually from human patients to build those tissues, so we can also use these as a way of doing personalized medicine and designing and developing drugs that will be effective for a certain patient based on their specific background and genetic information. So thanks for being here.
Thank you.
Hi, everybody. Yes, sorry. Hi, everyone. I'm Unju Chung, and I'm an assistant professor in biomedical engineering. I've been at USC for a little over 4 years now, and I got my bachelor's in molecular biology. Oops.
Oh, sorry, did that distract you? I'm sorry, that was not.
No worries. From the Claremont colleges from Scripps, and then I got my PhD in BME at Northwestern University in Chicago. And then I stayed there a little longer. I did a postdoc at the University of Chicago, and then came to USC. I teach a graduate course and an undergrad course, both in nanomedicine, and that is also what my research is about. So we develop these nanoparticles, and we can place drugs or diagnostic agents, and we can try to manipulate them so that they can go specifically to a diseased tissue or a diseased organ, and try to limit, its dilution in other places. So the idea is to decrease side effects, but increase efficacy. So yeah, welcome everybody.
And finally, I'm Christina Zavala. I originate from Texas, so born and raised in Texas. Then made my way over to California, where before starting at USC, I was at Stanford for several years. And then came to USC about 3 years ago, and am now an assistant professor in the Biomedical Engineering department. And I teach the Intro to Biomedical Imaging course, which introduces students to all different types of imaging modalities that we use both clinically and pre-clinically. My lab focuses on developing new imaging contrast agents mostly for cancer detection. So we want to be able to either help physicians detect cancer earlier or help them during some sort of procedure, give them image guidance, maybe like for surgery, something like that. So that's what my lab has been focused on. And we have several undergrads in my research lab right now, and we'll probably be recruiting more once we get back to in-person events, and really excited about meeting and recruiting some of you guys to USC.
Awesome. Well, again, thank you, Dr. Yen, Dr. McCain, Dr. Chung, Dr. Zavala. Thank you for making your way and taking time to meet with our students. I really appreciate it. Once again, for everyone that's here, this is how today's going to work. I'm going to moderate a bunch of discussion about the discipline, about the program, about the department, about the research, and that will take probably about the first 20 to 30 minutes. And then the latter half of the program, we're going to open up to Q&A. A few of you have already asked questions. I'd ask you to refrain from asking questions at this point. So please hold all questions for the time being. What we'll do is we will have time to ask questions toward the end, and I promise we will do everything we can to answer as many questions as we possibly can in today's session. But one thing we will not be covering today is anything related to admission or the application process. And so some of the questions have already been about that. So what I want to make sure that you understand is that we have specific admission information sessions. Go to viterbi.live/events where you signed up for this event, and sign up for one of our admission info sessions where we go over that in detail and we can talk to you very much specifically about that. But now we have faculty, so let's talk about biomedical engineering. The first question for you as a panel, and whoever would like to jump into this, is a seemingly simple question, but complex in its answer, I'm sure. What the heck is biomedical engineering?
That is a great question, Paul, and that's actually a question that I posed to my freshmen on the first day of class, because I asked them what their impression is.
And then you fail them out. They're not done. They don't get the answer right. They're out of there.
Yeah. Well, what I try to do is I try to give them a sense of how broad it is. And there was actually a question about that. And it covers a lot of things, but in general, I would describe BME as a discipline that is geared towards improving human health by applying the sciences, so physics, biology, chemistry, and engineering. And I tell my students in my class that BME is still engineering, so that we still rely heavily on engineering ideas, engineering approaches to solving problems, and biomedical is still is the adjective. So the engineering part is the emphasis, and we still rely on core ideas that you would probably learn in any other engineering class, in mechanical, chemical, or electrical engineering, but the application is different, and we are geared towards improving human health. That could be from anything from making devices, making tissues, having better drug screening techniques, whatever problem you're after. But again, the fundamental ideas are rooted in classical engineering disciplines.
That's a great answer. Anything you'd like to add from the rest of our faculty?
No, I think that was great. And I will say that that's actually what really drew me to the field, was that it is so interdisciplinary. So I really, one of my favorite things about biomedical engineering is all the different languages that we get to speak. So, we need to learn about DNA and cell biology, but also thermodynamics and, all these different fields. And we are really kind of the integrators. We get to bring all these fields together and have an impact on human health. So just to add that.
Thank you. Can we discuss a little bit more about how the biomedical engineering curriculum, the undergraduate curriculum, is set up at USC? I'll start you off with letting you know that everyone there are 4 different degree programs. They're all biomedical engineering degree programs, but there are 3 specific emphases should someone choose to go through it. So there's a biomedical engineering degree, biomedical engineering with an electrical engineering emphasis, biomedical with a mechanical engineering emphasis, and biomedical with a molecular cellular engineering emphasis. So can we describe what the curriculum's like, and essentially from a 30,000 foot view, like how does one progress through that, and what are we covering?
Well, sure, I can. I'll go first on that. So all students will take BME 101, so that's my class. And in our class, we go over, in effect, what you might see should you choose to major in just BME or if you decide to pick up an emphasis. So we will spend a few weeks talking about momentum or mechanics. So that will be a few weeks when we talk a little bit about charge. So that will be related to the electrical emphasis. And then we talk about mass and ideas of, for example, of conservation of mass, and that will relate to the cellular and molecular. There are a number of classes that all students will take. So you'll take courses in computational methods, statistics. There will be classes in instrumentation, but then if you choose an emphasis, there will be additional electives or courses that you'll take perhaps in, for example, if you did a cellular molecular, maybe in chemical engineering, or if you were mechanical and you take additional courses in mechanical engineering, you certainly would take biomechanics. And a similar thing would happen if you were doing the electrical emphasis. So there are a number of core classes that everyone takes, but then the electives that you could choose from or the additional classes that you would take might be more rooted in the different emphases. And so they might have connections to other departments. And of course, you'll also take your basic, your physics, bio, chem. I think maybe the electrical emphasis may not require things like organic chemistry. I'm not quite sure about that, but there may be some of those exceptions that are there. But that's all on the bme.usc.edu website too. If you go to bme.usc.edu and then click on undergraduate, they have a list of the sequence that you would take for each emphasis or with no emphasis.
Other thoughts on courses that you would take or?
Yeah, I think so. Based on what the first question, because BME is so broad, that's why we have the different tracks so that you can specialize. And I think freshman and sophomore year are pretty similar across the board because there's so many prerequisites that are common for all. And it's more junior, senior year with some of the electives that are more within our department where things branch off a bit more between the different emphases. But yeah.
I just wanted to add that I think the majority of the students are just general BME. And if you wanted to have a little bit more of a unique identity, maybe that's related to what you want to do after college, or you had a particular liking for that specific, track. But I think at the end, there aren't that many differences. I think you will get a really good core BME curriculum regardless. And then, as Megan stated, and Jesse, there are some electives that are, just fine tuning that for that specific emphasis.
Yeah, I think the thing that I'll add onto this, and the thing that you've all said, but I want to kind of underscore, is that you don't have, as a high school student, as you're going through this process of applying, you don't have to have this figured out yet. This is an experiential process, and understanding what BME is, that first question I asked, is probably the hardest part. And then as you get into it, you will start to navigate and kind of move toward things that you enjoy doing. And so as you start taking courses, you'll recognize that you like certain elements, as some of our faculty already discussed, like whether they're involved in imaging or whether they're involved in more of the biomechanical properties of it. Like you might understand that you like that more or better than something else, and draw yourself to it. So you will decide whether you want to emphasize or specialize in something as you go, but this isn't something you're supposed to know before you get started. And no one track is more successful than another. It's just more about what interests you and where you want to get into down the road. So hopefully that's a nice summary to that. And I put a link to the curriculum inside of the chat for everyone to review the exact course plans, but you'll notice it's nothing to worry about really right now. We get a lot of questions from high school students, and this happens a lot inside of biomedical engineering, where, biomedical engineering sounds cool, but I'm really into lots of things related to biology, right? I mean, I'm thinking about medical school. I'm thinking about, I love neuroscience. I love the brain. I'm interested in something related to math and science, but I don't know what I want to do. So can I do all of these things, or how does someone study biomedical engineering and still have these interests in other areas? And usually neuroscience is the most popular thing that they want to add on to that.
I think what's exciting about biomedical engineering is because it is so broad, and like really any health problem could use new engineering solutions and across all different levels. So just thinking about neuroscience and the brain, like we need new tools on the level of DNA and manipulating DNA and understanding how proteins within neurons work and degenerate in certain diseases, all the way up to how do we actually record signals from the brain and how do we image the brain. So going from very small scale, which is more molecular cellular related to maybe recording instrumentation, right? That's more electrical engineering related. So you can kind of hone your interests in all these different areas and find a nice blend between different science and engineering disciplines and apply those to a biomedical problem that either interests you or you have personal connection to, et cetera. So yeah, I think like you mentioned, it's really, I think, because the first couple of years of the curriculum are relatively general, that does give you the time to explore and go to seminars and talk to professors and try to get involved in research labs and find what really excites you and what resources are available at USC that you can take advantage of.
Yeah, I wanted to just emphasize for the medical school portion that you could be pre-med really with any major, even an econ major. It's just about making sure that you are well prepared to, take the MCAT and go to medical school. I think BME is really nice because it'll do that naturally. The BME courses just overlap with things that will prepare you well for medical school. So there are definitely a lot of students that are BME and also pre-med at the same time. And then in terms of neuroscience or maybe other types of diseases, cancer, is another big one that many students are interested in. Right, like Megan said, you can explore that a little bit deeper through research, whether that means you're going to get involved in research, or now this is really nice because you have Zoom and virtual seminars that you can attend, even now as high school students, to really get an understanding and a deeper flavor of what that means. Like, what does neuroscience research mean today? And then you can also tailor your courses too. Of course, you can look into, what courses would have a bigger emphasis in one, specific disease type or application of interest. So you have multiple ways to do that.
I just wanted to reiterate and emphasize the research component. I think it's one of USC's BME program's strengths, and USC in general offers several undergraduate research programs. This is something coming from Stanford. We didn't have as many opportunities for undergrads to actually immerse themselves in hands-on research opportunities with faculty members like ourselves. All of us have research labs. And I was a little apprehensive at first about, undergrads in the lab, but my undergrads are like an absolute treat. And I look forward every year to recruiting new undergrads because they're really what, spark, give that special spark to the lab. It's really actually something special that I wasn't anticipating, but I absolutely love having undergrads in the lab. Their enthusiasm, they're bright-eyed and they just want to know, they're curious, and I absolutely love it. And I think it's actually one of the bigger strengths of USC as a school in general is their undergraduate research opportunities that are available. So many research opportunities, and we can get into this a little bit more later. I didn't know if it was on the list of things to do, but I really want to emphasize how important it is, and especially for our pre-meds out there. It's so competitive these days, right? And med schools love to see that research element. Graduate schools love to see that research element. It's just a wonderful opportunity to have that perspective. And even if you are going pre-med, taking a step back, and I have several pre-meds in my lab actually as undergrads, and I've actually gotten them to consider taking a more MD PhD route than just the pure MD. And it's because they were never given an opportunity to really see what the PhD route could offer in terms of really contributing something new to the field. Pairing that clinical knowledge with the engineering knowledge, I think, is like the home run. And I'm always trying to encourage my students to think about the research.
Right. And that's exactly where I was going. So I'm glad that you made that transition, which is, let's talk about research, and also to kind of tie some of these questions up, which is, research at the end of the day is not done by just biomedical engineers. It takes an interdisciplinary, multidisciplinary effort. So can we talk about your areas of research and how undergrads are involved?
Who wants to go first? I can go first. So one thing related to your question and what Christina was just saying, I think also another strength of USC and biomedical engineering at USC is we have a very strong medical school. So most of our labs are on the kind of University Park campus, and that's where all of your classes would be and where many of the research labs are. We also have a medical campus that's a few miles away where there's also research labs that also take undergraduates. And so those are more, of course, clinically related, right? They're there in the medical school. We also have affiliation with Children's Hospital Los Angeles, which is another place where there's a lot of research going on, and several other places around the city. So, being in a place like Los Angeles where there is just it's just so large, right? And so there's a lot of resources and opportunities there as well. In my lab, so we collaborate a lot with labs in the Department of Stem Cell Biology and Regenerative Medicine, which is located at the medical school. And those are actually my favorite projects, are the collaborative ones. And so, we're an engineering lab, so we make a lot of kind of small devices and surfaces, things like that for growing human cells basically outside of the body and assembling them into tissues that look and act like tissues in our body do. And we try to design these surfaces or devices so that you could grow many of them in the lab and be able to test drugs on all of these at the same time. And as I mentioned earlier, be able to use cells that come from specific patients. So when I've had several undergraduates in my lab, actually, especially when I first started my lab, I had almost exclusively undergraduates. And so I've really had some great experiences with them, like Christina mentioned as well. Usually I start them out on a project that's more on the device fabrication side. So not really touching living cells yet, just because that takes a lot of time and training and kind of just exposure to what we're doing in the lab. And so for an undergraduate who's probably not done any research or been in a lab before, that's kind of a nice introduction to what we do. And it also fits better with their schedule. So especially during the school year, when there's kind of just a few hours here and there that they can squeeze in the time, I try to fit a project that works with that. So they're usually working under, or especially when they start, they're working under the close mentorship of a graduate student or a postdoc who will train them and teach them to do certain aspects of their project. And then depending on that student and how interested they are and how motivated they are and how well they do in the lab, I kind of gradually increase responsibility as time goes on. And where I think the undergraduates have had the best experience is if they're able to stay during the summer in the lab, because then they can work full time and they essentially become like a graduate student during that time. So especially if a student stays for the summer, I make sure that they learn a lot more skills, so they would learn things like cell culture and be able to grow and maintain their own cells in the lab. And yeah, get really integrated in research projects. I've had undergraduates on a lot of publications coming from the lab, and right now 2 of the graduate students in my lab worked in my lab as undergraduates. So that's also really great. So you kind of are a step ahead in that respect as well, if you get involved in research as an undergraduate. And that's not true even just for my lab. If you do any type of undergraduate research, right, you're always just in a better position for graduate school. Even if you go to a totally different field, just kind of learning the mindset of how do you do research and how do you develop and think about these projects is a really important problem solving skill for no matter what you end up doing in life. So.
Yeah, so I think the model that Megan described is a pretty typical model. That's typically what I also do, although I don't work with tissues and cells. I build devices, ultrasound devices, and so usually undergraduates, at least pre-COVID, would start working with graduate students on learning various transducer fabrication steps, where you don't necessarily have to understand all of the physics and the math behind how a transducer works to build a transducer and to test it. And so we get started on that. And then we gradually work towards perhaps some of the more theoretical ideas behind, well, why are we doing what we're doing, and how can we improve things? And then eventually, if they continue with me for an extended period of time, they can sort of start their own project to a certain degree, or maybe a mini project within a larger project. So there's always this gradual transition to some degree of some kind of independence. So they get trained in basic physics and the science and basic steps or techniques that we do in the lab, and then they eventually learn how to apply that to new situations.
Any other thoughts?
I guess the only, yes, I also have undergrads in my lab, but I guess the only thing that I wanted to just note was that there's a lot of undergraduate fellowships for research at USC that is, I think, very unique to USC. So they're competitive, but there is plenty. And so I think it does give, a high percentage of being able to obtain funding for yourself. And I think that is always great for whatever you do next, whether that's medical school, grad school, or going to industry or whatever. So that helps build your resume. It also kind of helps you think about the project a little bit more and put it down on paper and kind of work through that step of, I guess, the scientific method, just to bring that up, and then kind of put it in the context of, what can I contribute? So I think that's a really nice, characteristic of USC. Yeah, I also have lots of undergrads, and depending on, how long they stay and their interests, I've definitely had undergrads that have been the first author of publications. So really, we just kind of match, the interest and the commitment of the student themselves. So I think the sky is really the limit here.
We talked a lot about grad school and talked a lot about medical school because it was kind of some of the framing of the questions. But a lot, a good majority of our students are going directly into industry. So where do our students go? Where does this lead to when you have a degree in biomedical engineering? What types of jobs? What types of companies? What are they doing?
I'd actually like to mention that, step in here, because I don't know much in terms about, I've never done industry myself as an academic, and some of us who haven't had that industry experience often, aren't sure about how to best mentor a student as a researcher who want to go industry. But I can say from my lab, my undergrads, actually, there's so many different industry related companies that come out to the career fairs and recruit for the summers. And so several of my students have actually informed me about all the industry opportunities that are out there. So of my students, I've had people go to companies like Abbott, Merck, Edwards, as well as Medtronic. So Genentech, big players in industry. And I'm so certainly proud of all of them, because I think being in the research environment actually wanted those industry folks to look at them more carefully, because they've had some sort of research experience, because a lot of these places are, research-based industry companies. So they appreciate the fact that they were first in a smaller academic research setting and then wanted to explore industry. So I was actually surprised, but I wouldn't have really been able to name any of those companies without my undergrads informing me about all the opportunities that they've had themselves as USC BME students. So I thought that was really neat. And they're always talking about their summer research experiences in our lab meetings, and I get to see what they were working on. And it's really a treat to see the diversity and the interdisciplinary nature, because all those companies are pretty different, offer different sorts of things. So.
Yeah, I just wanted to emphasize that the students often do get internships pretty successfully, and then they are able to secure a job after they graduate. So it's the students that go into industry, I've never seen them take a gap year. They go pretty much directly right after college. The students that do take a gap year are probably the ones that are applying to medical school and are, taking the MCAT or doing other things. However, I have had students that do go to medical school that go to like consulting for the year. I've seen that a lot, in addition to the ones that do go straight to industry. And then I've also had students that go to dental school as well. So yeah.
Yeah, I mean, my favorite example is, if you want to know where biomedical engineers go to work, next time you're in a doctor's office or the hospital, just look at the names on all the things around you. With pharmaceuticals like Baxter, Medtronic Medical Devices, Johnson & Johnson, Stryker, Abbott, all these different companies, everything that's inside that medical facility had biomedical engineers involved in it at some level. And then obviously imaging companies as well, GE, for example. And there's tech consulting jobs, as you mentioned, most of the consulting big firms like Accenture or Deloitte, PricewaterhouseCoopers, but also there's healthcare consulting like GE Healthcare as well. And students are interning with these companies regularly, going off sometimes to co-ops and ultimately full-time positions after graduation. So it's a very prosperous next step. My last question, and then we'll open it up to Q&A from our audience who have been eagerly dying to ask questions, is this last thing that we put in the poll. And so it's always a fun question. The faculty mix it up a little bit. The one that won, this is the question that everybody voted on, was, if you were not a professor, what would your younger self wish you were doing professionally?
That's a good one.
I think Megan and I have the same answer for this, actually, which is something that we've really connected on, like coming to the BME and actually finding someone who had a passion for the same exact thing.
I'm dying to know.
We both want to work for Disney.
Doing what?
Well, I think we both wanted to do animation, be Disney animators. We grew up with Disney, both of us, went often to Disney World. And now, being so close, we each have had our annual passes at Disneyland. So we're both huge Disney fans. And Megan, take it away.
Yeah, same. I probably would have ended up as an Imagineer, now that I know kind of how things, the passion for science and engineering as well. So, but yes, Disney, graphic design, those types of things.
So if you go to the park, what's your favorite attraction? If it's post-COVID, pre-COVID times, when it's open, we're safe again, where you have your annual passes, where do you go? What's your favorite ride or attraction?
Mr. Toad's Wild Ride. I'm going to call it first, Megan.
I was going to say that I thought it was going to be too fringe.
That's not fringe. That's awesome.
It's a classic. So.
Yeah.
Well, fun fact about me is that I have a Disney family. My dad worked at Disneyland through the 70s, and he was a jungle cruise skipper.
No way! That's so cool. Oh my God.
He holds the record for the most continuous trips on the jungle cruise in one day. That will never be broken because they changed the route. They made it shorter. So he holds that record for eternity, and he will gladly tell you about it over the course of a 12-hour day. He has many stories about it. So did
you get free passes then?
No. Well, first of all, that was before I was born. He was there late 60s, early 70s. And then, I was born after that. But what I did get a private, while his friends continued to work there and rise up to senior executive levels, because they all did. They all went to like head of security, head of whatever. One friend was there when I was a kid, and he was operating the Mark Twain steamboat. And so as a 4 or 5-year-old, and I actually have the certificate, I became an official captain. I have a certificate signed that I'm a captain of the steamboat, but I've never put it to use yet. So
that's another big perk of USC, is you are driving distance to Disneyland.
That's right. Yeah, keep that in mind, everybody.
Jesse, and we took over this whole conversation. Sorry, Jesse, Unju.
For me, it would be two things. These would be very different. One would be a professional golfer. I am terrible at golf, but I would love to be a professional golfer, get to travel, get to play golf. What else?
That's awesome.
And if I couldn't be a professional golfer, I'd probably be a cook. I like cooking a lot. So I sometimes have fantasies of owning my own food truck.
Really? What would you be serving in that truck? And now I want to know.
It'd be a barbecue food truck. So brisket, pork,
I'm in.
pork shoulder.
Jesse, you're gonna invite us over for a department. Yeah, barbecue. I think.
Yeah.
I'm telling you, just the 5 of us right now. I'm planning a party in my head right now. That's all happening.
We'll go for brisket and then go to Disneyland after.
There you go.
Sure.
Benji?
It's kind of sciencey, but I think I wanted to be a marine biologist growing up. I watched Voyage of the Mimi. I don't know if anybody else watched Voyage of the Mimi. Yeah, in elementary school. Mm-hmm. And I was like fascinated by the humpback whales and doing the boat and learning more about them. So I think, and following them. So I think that would be my alternative profession. Yeah.
Voyage of the Mimi stands out so much in my elementary school years. And it's like this memory that I have. And I just found this out like 2 weeks ago. That was Ben Affleck's first acting gig.
What? I thought it was real.
No.
I didn't know Ben Affleck was in there. I need to go check it out. Wow.
There you go. I am spouting knowledge today. Look at this. Okay, let's get to everyone's questions. So for those of you that were not listening and you asked questions when I told you not to, I'm deducting 10 points from your application when you apply. So I'll go back through the names and figure that out. But let's actually go into the questions. So go ahead and use the Q&A feature and type your questions in. We'll get to as many as we possibly can. And a lot of them will be similar. So I'm going to try, don't go to the chat, everybody. Don't go to the chat. Come on, Akshay, I'm looking at you, dude. I know who you are. Okay, let's just go to the Q&A feature because then we can moderate it. In the Q&A feature, there is a question here that's interesting about prosthetics. And sometimes people find their way into biomedical engineering because they love the idea of prosthetics, maybe even robotic prosthetics. Dr. Loeb has done some work on this. Can any of you speak to this idea and how that is either flourishing or not at USC?
I don't think any of us do prosthetics.
I know it's hard to speak about someone else's research area, but anything you can share.
I can add a few things. So when we talk about prosthetics, I think most people think about artificial limbs, artificial arms or hands or feet or legs. So Dr. Loeb works on some of that to some degree, I think, but his expertise is more on what you would call a neural or a neuromuscular prosthetic. So it's a device that tries to restore control of your limb. So if someone has, for example, a severed nerve, can you implant an electrical device to restore control of the arm or the leg? He also does have projects on restoring or giving robotic hands the sensation of touch. So robotic hands are very good at picking things up and holding things and doing various tasks, but they don't really have good capability to sense. For example, if I'm holding an egg, well, how much force do I need to hold the egg with, right? If I hold it too lightly, it drops. If I hold it or squeeze on it too hard, it gets crushed. So how would I know how much force to apply to the egg? Some other things are sensing texture. So if you're like me, you're very nearsighted, and when you wake up in the morning, you kind of feel around next to your bed for your glasses. So you're using your hands to see, basically, right? You're feeling around to say, okay, well, here's my bedstand. Okay, there's my lamp. Okay, this is where my glasses are. So he's trying to give that sensation of touch to robotic hands to say, okay, well, this is a rough surface, this is a smooth surface, and even trying to identify the exact kind of surface. And so those are just some of the examples of the things that he's doing. There's also a number of people in other departments that are affiliated with BME who do with robotics and moving robotic arms and hands. So that would be kind of the degree of prosthetics that you might see. And of course, there's other prosthetics. There's a visual prosthetic, so that's a device that basically makes the blind see again. And then there's a memory prosthetic, which is a device that is implanted in your brain, designed to help people maybe suffering from memory loss to be able to transfer short-term memory into long-term memory. So prosthetics is a very broad term, as I came to find out when I first came to USC. And it's not just necessarily the the hands and limbs that we think about, although it is that as well.
Thank you for that. There's another question here. I'm sorry, I've been going through all these questions. We have a lot of questions. We're not going to get to all of them. Some of them are overlapping, but I did just find one that I wanted to ask. And I've lost it. Okay, well, let's do this one. I think this is more of a potato type question, or tomato type question, which is, how would you define the difference between biomedical engineering and bioengineering? If you think of it from a high school student's perspective, they look at all these universities and anything with bio is all over the place, right? I mean, even at USC, we've got biomedical engineering, 4 different areas of it. There are different biology majors. There's quantitative biology. There's computational biology. There's another question related to bioinformatics that I want to kind of weave into this question as well. How should a student that's really interested in math, science, and has some sort of desire for technology navigate the undergraduate program's diversity, even across different universities? I threw a lot into that question. I'm sorry. I was just trying to get a lot of stuff going there.
From my perspective, I don't think there's a difference anymore between biomedical and bioengineering. The one distinction that I make sometimes is biomedical is like there's kind of a clear way that that's impacting human health, versus bioengineering might be more fundamental. So it might be like engineering a bacteria to make some type of product or something like that. So you're still engineering biology in some way, but there's less of a direct connection to human health. But otherwise, I don't think that there's a huge distinction anymore in the field. I don't know how others feel, but. And
thoughts? The one thing I would add in is that pay attention to the universities. I mean, sometimes they kind of throw bioengineering around when it's not really an engineering school. They might just have kind of an inflated science program, which is neither good nor bad. It's just different. And so pay attention to exactly what engineering is. Biomedical engineering, in the long haul of history, has kind of had this, no one's had one definition of biomedical engineering over the years. That's also why accreditation standards were so weird for years going on to this, and half schools were accredited, half schools were not, because everybody didn't have an exact definition of what should be included in a biomedical engineering degree. And that's sort of simmered down now. But it's a relatively young discipline because it's an offshoot of different areas. Our program was born out of mechanical engineering and electrical engineering. So obviously it started building those devices. But we also have elements in tissue engineering. We also have these elements in kind of the quantitative nature of it, and so the molecular cellular element of it as well. So there's so broad, as we talked about. There's not a wrong way to go. But I mean, is that correct for you all, or is there some other thoughts you want to throw into that?
Yeah, I think there's not really much of a difference, but I agree. Sometimes it can get me a little bit more like synthetic biology for the bioengineering schools, where they're like helping with like energy production or something through bacteria. But one way to get a good understanding of the emphasis of the different schools is probably the faculty research profiles that'll probably build out what that department might have a bit more expertise in overall. But overall, there's never a school that has a major in bioengineering and biomedical engineering, right? So I would say they're pretty synonymous. Yeah.
Yeah, you might also want to take a look at the adjacent word next to the bio word, right? If you have computational biology, chances are that area is rooted in computer science. So if you're gravitating towards computer science within the broad area of STEM, then maybe computational biology might interest you. If you're interested in bioinformatics, well, informatics, before there was bioinformatics, there was informatics, right? It's a handling of large amounts of data in other areas. And so you might want to look into that, or if you see that is interesting to you. So there's always generally some kind of adjective next to it, or maybe bio is in the adjective and then there's a noun. Look at that, and that's really where that area is rooted, and then the application is in biology or has biomedical applications. So at least that's my take.
Yeah, and I would also specify, and this overlaps with some other questions. This is typically how we know we're talking to a prospective engineering audience, which is They want to know the right path. What's the right answer, right? I want to get into the right degree program to do the right thing. And we all know that that's not how life works, right? It's not like all of a sudden, all these jobs that people have, all of the technologies that are out there are interdisciplinary in nature, multidisciplinary. And biomedical engineering is a great, way to start your educational path towards any of those things. There's a lot of great questions here about, like, I want to go into oncology, which biomedical engineering degree is right for me? I want to go into I forget what it was, but some sort of surgery. What's the best biomedical engineering for me? I want to go into drug development. What's the best biomedical engineering development for me? It's the beginning of an educational path. And there's not necessarily one right answer to any of this stuff. And biomedical engineers will be doing jobs in bioinformatics. They'll be doing jobs in computational biology. It's not like one undergraduate degree leads to one thing.
I like this question about, is the rest of the faculty as fun as y'all?
That's where I was going. I was going to put that on you because you guys have to answer this question. I'm not allowed to.
I'm like, well, yes, at USC they are, but not anywhere else. Just a little plug for us. That's a good question. I love it. No. I was just teasing.
I do want to know, like, we'll get along.
No, we're pretty tight.
Yeah, well, especially after we have this party with Jesse's food truck. It's gonna
Jesse's food truck's gonna start.
Yeah, I'm gonna make a Costco run.
Get that smoker going, man. Okay, so the other thing is, this is a serious question that leads off of that. Are they fun as y'all? What drew you to coming to USC? You've been at different places, and why here, and why'd you stay?
Why'd we stay?
Well, like, obviously you could have left. Like, there's different jobs.
Yeah. Well, Megan was mentioning how we have a medical school, and I kind of glossed over that. I also have a courtesy appointment in surgery and medicine, as well as chemical engineering, just because, like everybody else, the work is very interdisciplinary. But I really appreciated schools that have medical schools, because I think you have access to just different facilities and different collaborations. And that was very important to my work. So that was one part of it. So I think USC is big enough where you can find lots of different interesting work that can be exciting to one person. And there's just a diversity of a lot of different things going on, but it's small enough because it is actually physically separate from the medical campus, where it feels sort of like a tight-knit college campus. So I don't know how many of you have ever been to the campus, but when I interviewed at USC for faculty position, that was actually my first time coming. And I'd always thought USC was this huge school, just like you'll just get lost, but that is not the flavor that I get when I came to campus, and every day, even now. So it feels very warm, and it feels like you can find a place for yourself here, but at the same time, it has so many resources. You can go to the medical campus. We are also affiliated with Children's Hospital, which is another different direction, 8 miles away. And then we have some facilities near on the west side as well. The somebody correct me, it's the
information science.
Information science, yeah, exactly. So there's just like, there's a lot that USC offers, but at the same time, it doesn't feel like you'll be lost in there, So I thought it had a really good mix of things.
I came to USC because for our department, Biomedical Engineering, there's actually nobody really working in cell tissue engineering, and they wanted to specifically grow that as an area. And so when I interviewed, I got to tour what eventually would become my lab space, and I was really impressed with like the facilities and resources and investment that I saw from the department and the engineering school to grow the area of research that is what I do. And so I saw it as really an exciting place for me to come and grow and kind of be the trailblazer for our department into this research area, and do that in a very supportive environment as well. So I think what also I could feel kind of before I started, and what really solidified after I got here, is just like support across all levels. So faculty supporting each other, faculty supporting students, And just everybody wants everybody to succeed and do well. There's no competitive spirit or attitude at any level that I've ever experienced. So I've really liked that. And then like Unju mentioned, the really resources for research and collaboration and everybody being open to that and really wanting to do that has also been a great reason to stay.
I wanted to bring up real quick, there was a question, I didn't want it getting missed about support for women in engineering. And one of the things I wanted to mention is that USC has officially reached gender parity, which is a huge engineering, which is a huge accomplishment for any engineering program, and a first for us. And yes, there are resources that support women undergrads specifically. We have actually a society called Women in Science and Engineering that supports not only the undergraduate level, but also the graduate, postgraduate, or postdoctoral, and even for us as faculty, all three of us are have been given resources and specific support from that group. And there are fellowships that they support for research to do in the summer specifically for women engineers. So that's one resource. It's not the exclusive resource for undergraduate research, but it is one. And I just wanted to point that out because I think it is something to take note of as an accomplishment for us here at USC.
Absolutely, thank you for that. We have time for two more questions. This one is about genetics. Sometimes students have an interest in genetics as they come out of high school, and they look at BME and they'll look at the curriculum and say, I don't see genetics here. Can we talk about how genetics might work its way into a curriculum and probably how it's much more on the graduate side of things?
I can speak to that because so you will learn genetics for sure because you have to take some of the biology classes during freshman and sophomore year. And then my course is Introduction to Biomaterials and Tissue Engineering. And actually the first third of my course is devoted completely to cells. And so we learn about a lot of different types of stem cells. And we learn about how to manipulate stem cells from the level of their DNA and from genetics. So things like CRISPR-Cas9, which many of you have probably heard about. The Nobel Prize was just awarded for that last week. So we spent a whole lecture talking about CRISPR-Cas9 and gene editing and how that can be leveraged as a tool to make stem cells and cells into, if you want to make a heart cell or a brain cell, et cetera, and then use those for tissue engineering. And so then the second part of the class is focused more on scaffolds and materials and more kind of the engineering side of things, or traditional engineering side of things. So for the cellular molecular track, I would say genetics and thinking about manipulating the DNA inside the cell is really a key part of that. We don't really have a dedicated course to it. Instead, I think we all just kind of touch on it when it's relevant to what, the larger theme of our course.
Anything else? Other than that, we'll go to our last question, which is, why should a student choose to study biomedical engineering at USC versus other great institutions?
I think that whole research emphasis is a huge one. That needs to be emphasized. I came from Stanford University, and they didn't have an infrastructure the way that USC does to support undergraduates, at least in the department that I was at and within the medical school. I just feel that there's really, really great, rich resources for exploring this research element. Someone had asked about, are there paid opportunities in the summer? Yes, there are paid opportunities in the summer. You have to apply for them. They're competitive, but they do exist, and multiple types of fellowships exist. So I have several of my undergrads who didn't originally have fellowships, and they took time out of their own summers to come and work, but then eventually they applied and got in and were fully paid for the summer. So I can't emphasize enough. I think that's one of the real strengths that BME can offer on my end. I don't know about everybody else.
Anything else? That was a great answer. I think to take classes from each of you. I think that would probably be the answer.
I was going to say our department has grown a lot in the last 6 years, I guess 6-7 years. So we do have a lot of kind of new faculty from a lot of different institutions and a lot of different areas. So I do feel like we're kind of, you know, at the cutting edge for a lot of different fields because of that. So yeah, I think our department has kind of been up and coming for the last few years. So
yeah, to add to that, oh, go ahead, Unju, go ahead.
Oh no, I was just gonna give you a plug. I would just want to say that the older faculty though have been there to support us.
Old.
Wow. Not older, but the folks that have, you know, started the program and have been there have been, you know, solid mentors to us, and you know, they've established their research profiles as well. So that's been a great model for us. So I think, you know, on both ends, I think hence, you know, this is a wonderful place to be. Yeah, overall. Go ahead, Jesse.
Yeah, so what I would say is that, you know, while if you compare the size of our department to other departments, we may not be the biggest in terms of numbers, but I do feel that the areas that we do cover, we cover very well, and we are among the best in those particular areas. Another thing that I would add is I think that, again, from teaching BME 101, it's fairly apparent to me that the BME undergraduate community is very inclusive, and they want to see incoming freshmen succeed. They want to get you, they do a number of activities to help you get acclimated to USC, to find research opportunities, to connect you with people in industry, to serve as your mentors. That's something I certainly didn't have going to Duke, but it is, the student organization is very well run. They've won a number of awards for best student organization across campus. This is all clubs. And so that environment, I think, is something that is very unique and special to USC, where it's not like you're going to be, you know, it's going to be every, you know, person for themselves. There's going to be a support system for you, and these students have been through it, and they're more than willing to help you navigate all the issues of emphasis, which professors to take or not take, etc.
Well, on that note, I want to be respectful of everyone's times and also thank you all for joining us for this session. Dr. Yen, Dr. McCain, Dr. Chung, Dr. Zavaleta, I really appreciate you taking time to speak to our prospective students. A number of you were asking questions that were already answered earlier in the session, so you can watch a recording for this on our YouTube page. It's actually there now, youtube.com/Viterbi admission. We've been live streaming it there at the same time, so you can go back and watch it. Also, a lot of the questions that were asked that we didn't get to were all admission related, application related, student life related, and we have more events for that. Viterbi.live/events, admission info sessions 3 times a week, transfer info sessions every 2 weeks. Plus we have all student-led live chats every other Sunday night on different topics. Women in engineering was one of them. LGBTQ environment was last week. We have another one coming up on research, on all undergrads that are doing research. They're all really individually oriented. So we have so many events happening. Register for as many as you like to get more of your questions answered. In our admission info session, we get to every single question because we're devoted to answer your questions. Outside of that, make sure you apply by December 1st in order to be considered for merit-based scholarships. Go to viterbiadmission.usc.edu to make sure that you know all the information about that. You can always email us as well. Email us as well if you have other further questions. I don't know what just happened to my throat. Sorry about that. But other than that, I'm going to say goodbye. I'd love to keep you all on so we can schedule our Disney smoke party. But when I close the live chat, when I close it, it's also going to go away. So thank you. Have a great night.